Hi dear friends, in this video we are going to solve this packet tracer activity subnetting scenario. Friends, before coming to the configuration, if you are watching our channel first time or if you like to get these type of technical videos in future, consider subscribing and don't forget to enable that bell icon near to our subscribe button so that you will get the notification message whenever we upload a new video. Okay, here we can see our addressing table which is incomplete. We have to complete as per the requirements. Here we can see our objectives of this packet tracer activity. In part 1, design an IP addressing scheme. In part 2, we will assign IP addresses to network devices, and finally we will verify the connectivity. Now we will come to part 1, design an IP addressing scheme. Step 1, subnet the 192.168.100.0/24 network into the appropriate number of subnets. Here we have some questions. Based on the topology, how many subnets are required? Okay, coming to our topology, here we can see here one subnet, here is the second one, third one, fourth one, and here we can see the fifth WAN. So total we required 5 subnets. Here I will highlight all these subnets, right? So we will fill some color. Here we can see one network. Here we can see one network. Here is another one. Here is the fourth one. And here we can see the fifth one. So we required a total 5 subnets. Next is how many bits must be borrowed to support the number of subnets in the topology table. Here we can see each networks require 25 hosts. So if we borrow 3 bits from the host portion, we will have 8 subnets, where in each network we will have 32 IP address, 30 usable IP addresses. How many subnets does this create? Yes, if we borrow 3 bits from the host portion, we can create a total 8 subnets, 2 to the power of 3, it's 8. And how many usable hosts does this create per subnet? Yeah, already we told total we get a 32 IP address. In that we get 30 usable IP addresses. Note, if your answer is less than 25 hosts required, then you borrowed too many bits. Yeah, it's 30. Calculate the binary value for the first 5 subnets. The first subnet is already shown here. We can see that. Now here we will come to our IP address. It's 192.168.100.0/24. Here we are going to borrow 3 bits from the host portion, and here we can see we will get 2 to the power of 3 networks, that is a total 8 networks. Now here we are going to rewrite this IP address as 192.168.100.0/27. Previously we written this prefix as /24, and now we can see this prefix we written as /27 because we borrowed 3 more bits from the host portion. And here we can see our subnet mask. The prefix is /27, and here we put 27 ones and remaining 5 zeros. So once we convert this binary to decimal, we will get our subnet to mask. And here we can see our subnet to mask will be 255.255.255.224. Here we already told we will get a total 8 networks because we borrowed total 3 bits from the host portion. And here we can see those three borrowed bits and its possibilities. And here we return those 8 networks. So here we can see that which is marked in a red color belongs to the network portion, and the remaining 5 bits belongs to the host portion, which is in the black color. Calculate the binary and decimal value of the new subnet mask. So here we have seen that here is the binary subnet mask, and here we can see the decimal subnet mask. Next is fill in the subnet table listing the decimal values of all available subnets, the first and the last usable host address and the broadcast address. Repeat until all addresses are listed. You may not need to use all rows. Yes, so here we can see our subnet table. Subnet number, also we can see the network address, first usable IP address and the last usable IP address. And here we can see the broadcast address of each 8 subnet. Now we will come to step 2. Assign the subnets to the network shown in the topology. Assign subnet 0 to the LAN connected to the gigabit Ethernet 0/0 interface of R1. Assign subnet 1 to the LAN connected to the gigabit Ethernet 0/1 interface of R1. Assign subnet 2 to the LAN connected to the gigabit Ethernet 0/0 interface of R2. Then assign subnet 3 to the LAN connected to the gigabit Ethernet 0/1 interface of R2. Assign subnet 4 to the WAN link between R1 and R2. And here document the addressing scheme. Fill in the addressing table using the following guidelines. Assign the first usable IP addresses to R1 for the 2 LAN links and the WAN links. Assign the first usable IP address to R2 for the LAN's link. Assign the last usable IP address for the WAN link. Assign the second usable IP addresses to the switches. Then assign the last usable IP addresses to the host. Assign subnet 0 to the LAN connected to the gigabit Ethernet 0/0 interface of R1. Coming to our topology, here we can see our router R1 and the interface G0/0. Here we are going to use subnet 0 for this network. Coming to our addressing table, not the addressing table, subnet table. Here actually subnet number we started from 1. We will start from 0, 1. So it will be more clear. And here they clearly mentioned assign the first usable IP address to the router, and assign the second usable IP address to the switches, and assign the last usable IP address to the host. Here in this network 0, the first usable IP address is here. We will copy this address, and coming to our addressing table, for this device R1 interface G0/0, we will use this first usable IP address. And subnet mask, it's here already. We will copy the subnet mask. Default gateway, it's not applicable. Now coming to our topology, here we can see this PC1 is belongs to this network. Also here we can see the switch S1 belongs to this network. We will assign IP address for these 2 devices. Here we can see PC1, we have to assign the last usable IP address for this PC1. Okay, coming to our subnet table, here we can see the last usable IP address. We will copy this address. PC1, okay, subnet mask, the same subnet mask, and the default gateway, it will be the IP address of this interface G0/0 on this router R1. Next we will assign for this device S1 its second usable IP address. Here we already used the first usable IP address. Then the second usable IP address obviously will be 192.168.100.2. Then the subnet mask, and here is the default gateway. Next, here we can see assign subnet to 1 to the LAN connected to the gigabit Ethernet 0/1 interface of R1. Coming to our topology, here we can see that network G0/1, and here we can see those devices connected to the network PC2 and S2. Coming to our spreadsheet, subnet table, and here we can see network 1. Here we will use the first usable IP address for the router 1 interface G0/1, and here is the subnet to mask. Default gateway is not applicable. Then coming to S2, we will give then a second usable IP address. It's 34. Here is the subnet to mask, and coming to the default gateway, the IP address of this interface G0/1 on this router R1. Now coming to the end device, that is PC2, we have to assign the last usable IP address from this network 1. It's here. We will copy this address. Then we will go to addressing table. PC2, here is the address. Subnet to mask, and the default gateway is here. Next is assign subnet 2 to the LAN connected to the gigabit Ethernet 0/0 interface of R2. Coming to our subnet table, here we will use this network 2 first usable IP address. It's here. We will copy this address. Coming to addressing table, for the device R2 interface G0/0, we will use this address. And here is the subnet to mask. Default gateway is not applicable. Coming to our topology, here we can see these devices are connected to this network S3 and PC3. Okay, we will assign IP address for these devices. Coming to subnet table, here we will use the last usable IP address. It's 100.94. We will assign this address for our end device PC3. Here is the subnet to mask, and the default gateway, it's here. Then we will use the second usable IP address for this switch S3. It's 66. Then the subnet to mask, and here is the default gateway. Next is assign subnet 3 to the LAN connected to the gigabit Ethernet 0/1 interface of R2. So coming to our subnet table, here we can see network 3 details. Here we will get the first usable IP address. Coming to our addressing table, here we will give this address for the interface G0/1 for this device R2. Here is the subnet to mask, and the default gateway is not applicable. And coming to our topology, here we can see these devices are connected to this network S4 and PC4. Coming to our subnet table, here we will copy the last usable IP address, and we will assign for our PC4. Then here is the subnet to mask, and coming to the default gateway, the IP address of G0/1 on this device R2. Also coming to S4, the second usable IP address, it's 98. Then the subnet to mask and the default gateway. Then finally assign subnet 4 to the WAN link between R1 to R2. And here we can see assign the first usable IP address to R1 WAN link, and assign the last usable IP address for the WAN link on this router R2. that can be done. Okay, coming to our subnet table, network 4, here we can see the first usable IP address. We will copy this address, and coming to our addressing table, serial 0/0/0 on this router R1, we will give this address. Here is the subnet to mask, and this default gateway is not applicable. Then coming to this serial 0/0/0 on this router R2, we have to use the last usable IP address as specified. It's here. We will copy this address. Coming to addressing table, here is the address, subnet to mask, and default gateway is not applicable. Now we will come to part 2, assign IP addresses to the network devices and verify connectivity. Most of the IP addressing is already configured on this network. Okay, well, implement the following steps to complete the addressing configuration. Configure IP addressing on R1 LAN interfaces. We will do that. First of all, we will configure G0/0 on this router R1. We will get the IP address of G0/0. It's here. We will copy this address. Coming to R1, CLI, enable, configure a terminal. We will go to the interface G0/0 and we will set the IP address. We already copied the IP address. Then the subnet to mask 255.255.225.224. Now we will give no shutdown command. Now we will get the IP address for the interface G0/1. It's here. We will copy this address. We will go to that interface. We will press up arrow, and here we will give gigabit Ethernet 0/1. Then we will set the IP address. It's here. Only this address will change. Okay. We will paste it here. Press enter. Now we will give no shutdown command. Next is configure IP addressing on S3, including the default gateway. Coming to our addressing table, here we can see our device S3, and here is the IP address. Okay, I think we did not change this address. Second usable IP address. Here we can see the first usable IP address, and the second usable IP address is 66. Sorry, we did not change it. We will give 66 here. Then we will copy this address. Now we will go to S3 and we will configure IP address for VLAN 1. Coming to S3, CLI, enable, configure terminal. We will go to the interface VLAN 1. IP address, we already copied IP address. Then the subnet to mask 255.255.255.224. Then we will give no shutdown command. We will exit and we will set the default gateway, IP default gateway. It's 65. And finally, here we can see step 3, configure IP addressing on PC4, including the default gateway. Coming to our addressing table, here we can see PC4 IP address. We will copy this address. Coming to PC4, desktop IP configuration. Here we will give that IP address. We will change the subnet to mask to 224. Then we have to give the default gateway. Okay, we can verify that in our addressing table. It's here, 100.97. We'll give the default gateway. Finally, step 4, verify connectivity. You can only verify connectivity from R1, S3 and PC4. However, you should be able to ping every IP address listed in the addressing table. Okay, here what we will do, we will use this add a simple PDU and we will verify the connectivity. We will ping from PC1 to PC2. It's successful. From PC1 to PC3 it's successful. PC1 to PC4 it's successful. We'll try from PC1 to R1. Successful. PC1 to R2. Okay. PC1 to S1. Working. PC1 to S2. PC1 to S3. PC1 to S4. It's working. We know that we don't have any add a simple PDU option in the real time. We have to use only the ping command. So here we will try to ping from PC4 to PC1. We will get the IP address of PC1. It's here. Coming to PC4, command prompt. Here we will give the ping command. Ping to PC1. Here is the address. It's working. We can try to ping to all other devices. It should succeed. Okay, right here we can see our completion status. It's 30 out of 30. Dear friends, if you have any doubt, any suggestions regarding this video, please comment below. And stay tuned for the future videos. We will meet again with the next video. Thank you.